Hi and welcome. My name is Thijs. I'm the technical evangelist at Varnish Software, and I'd like to thank you for your interest in our Varnish Enterprise offering on the AWS Marketplace. In this video, I'll show you how to set up and configure Varnish Enterprise 6 for Red Hat on AWS in a matter of minutes. You probably already have a web server out there on AWS that requires acceleration. Well, let's get started and accelerate it using Varnish. You can now click the big Launch Instances button on the right upper hand corner to create the Varnish server. The machine image that we're going to use is not the standard operating system machine image. Please click AWS Marketplace to view AWS Marketplace images. Type Varnish, and your sixth result will be Varnish Enterprise 6 for Red Hat, which is the image we need. But of course, there's also a Varnish Enterprise 6 for Ubuntu. Click the Select button to continue. The pop-up you see contains a summary of the image, what it is, what it does, what its technical specs are, and of course the cost. For every instance type, you see the associated cost, which is the software cost, the EC2 infrastructure cost you pay to Amazon, and the total cost. Click Continue to choose your instance type. There are a lot of instance types you can choose from, but before you choose, you must consider the number of CPUs you need, the amount of memory you need, some of the storage capabilities, and of course the network throughput. I'm looking for an instance type that offers me about 5 gigabits of network throughput, and I'm going to go for the T3 Medium, which offers me 2 CPUs and 4 gigabytes of RAM. This is a relatively small instance type. You might want to go for a bigger one depending on your needs. Let's click Configure Instance Details to go to the next step and select the number of instances we want to create. We're going to go for one, but we can create multiple ones and group them in an auto-scaling group. There are plenty more parameters to configure. We'll leave them at the default values for now and go to the next step to configure storage. If you're planning to store most of the cached objects in memory, 8 gigabytes will do. There's not a lot of disk requirements, so we can just go to the next step to configure tags. We only need to configure a name tag, and we'll call this server Varnish. This will allow us to identify this server in the EC2 overview. And in the second to last step, we'll configure the security group, which is AWS's interpretation of firewall settings. And as you can see, you don't need to open up the ports on the firewall yourself. The security group was pre-configured and is part of the official machine image. So that concludes the configuration. We can go to the review and launch step where we get a summary of what we're about to create, and then just click launch to start the provisioning. But of course, before the servers are created, we need to select or create a key pair. There is already a key pair present for the web server. This is an SSH key pair that allows us to connect to the server via SSH. But what we're going to do is we're not going to go for an existing one, but we'll create a new key pair. So select create a new key pair, give it a name, Varnish makes sense here, and then click download key pair, which will download the key pair to your computer. And then finally, we can click launch instances, and that will create the servers. And in a matter of minutes, you'll have a full-blown Varnish server ready to use. So let's have a look at what Varnish already displays. We can select the Varnish EC2 instance and then copy its public IP. We can paste this IP address in a new browser tab and display the page. What you see is a landing page that confirms a successful installation. Click the Next Steps button to actually see a set of instructions on how to get going. These instructions range from backend configuration to customizing the caching behavior, setting the TTL, and knowing how to remove objects from the cache. But there's also operational instructions such as configuring TLS, doing parameter tuning, and knowing where to get support. Okay, let's switch the terminal to access the server via SSH to make those required changes. But before we can make those changes, we need to update the permissions on the varnish.pem file, which is our public key. We do this through the chmod command. We issue chmod 400 on downloads/varnish.pem to set the right permissions. Now use the SSH command, load the key via the -i parameter. The username is EC2 user, then add, put the IP address there, confirm, and you're in the server. Call sudo vim etc varnish default.vcl to open up the VCL file. Go to the backend definition and modify the backend's host. The IP address is the IP address of your web server and change the port to 80. Now navigate to the VCL receive section and remove the return statement that displays the synthetic welcome. That one is responsible for displaying the welcome page. So remove it, save your file, and restart Varnish through sudo systemctl restart Varnish. You can now switch back to your browser window, refresh it, and the landing page will be replaced with the actual output coming from the server. Let's switch back to our SSH shell to perform some more changes. The command we're going to run is sudo systemctl edit Varnish to edit the Varnish runtime parameters using a systemd override that is already part of the image. We'll modify the -s runtime parameter, which is in charge of object storage, and remove the 256 megabytes of malloc storage, and replace it with MSE, which is short for Massive Storage Engine. This is Varnish Enterprise's signature storage engine that supports disk persistence and, as the name indicates, allows you to cache large volumes of data. Another feature it offers is the memory governor that allows you to scale the size of the object storage dynamically. And that's what we're doing. Without any additional parameters, 80% of the available memory in the server will be allocated to Varnish. Save and close the file, and then run sudo systemctl restart varnish to ensure that these changes take effect. We can verify memory consumption by calling sudo varnish stat. It shows an overview of counters that are computed in real time, and one of those counters that we're interested in is main GMRSS. It represents the current memory consumption of Varnish, which includes object storage as well as other sources of memory consumption that are thread and process related. And the MSE G_space counter displays the available space in cache for storing additional objects. The memory governor controls the amount of memory that Varnish can consume through the memory target runtime parameter. And through Varnish ADM param.show memory_target, we can display that value. By default, this is set to 80%, which means 80% of the server's total available memory is allocated to Varnish. You can change the memory target value and assign either a percentage value or a byte value. Let's talk about TLS for a minute. The open source version of Varnish doesn't support TLS, whereas the enterprise version does, but it's not activated by default. And in this image, we opted for an approach that terminates the TLS connection using a TLS proxy, and then communicates over plain HTTP with Varnish. However, we use the proxy protocol for that interaction because it contains a lot more connection information that is useful for Varnish. The technology we're using is Hitch, which is an open source TLS proxy that is developed and maintained by us. We trust the technology and we already set it up in the image. So that means you can already navigate to Varnish using HTTPS. It has a dummy certificate, so it won't validate in your browser, but it's fully active. So allow me to show you how to configure Hitch and where to put the certificates. The configuration directory for Hitch is etc hitch. You'll find a collection of files there which includes the certificate but also the hitch config file. Open that one up to have a look at the configurable parameters. Let's talk about the front-end configuration first. It defines the host and the port on which Hitch is listening. The host is set to wildcard, which means Hitch is available on all available network interfaces, and the port is set to 443, which is the conventional TLS port. Then we need to set the backend, which will refer to Varnish. This is pre-configured on the local host and more specifically on port 8443, which Varnish also listens to for connections using the proxy protocol. While there are dozens of other configuration parameters to tune, the last one we'll cover is PEM file. It refers to the location of your certificate, and by default that's etc hitch testcert.pem, and that's the location of our dummy certificate. Please replace this value with the location of your actual certificates. And as mentioned in the corresponding comment block, you can actually define the PEM file multiple times in your Hitch configuration in case you need multiple certificates. Built-in SNI support will ensure that Hitch matches the right connection to the right certificate. Let's quickly close the Hitch configuration file and try an HTTPS call through the curl binary. The -i parameter will ensure that we only send a head request. And when we try HTTPS localhost, of course we'll get an error because the certificate couldn't be verified. But when we add the -k parameter, we will ignore these verification errors. And we get the output we expected. This also includes the H header that indicates that the object has been stored in cache for 359 seconds. When it comes to customizing the behavior of the Varnish cache and tailoring it to the needs of your application, you're going to need to write some VCL. The standard VCL that is deployed and that was featured earlier in the video is largely based on the built-in VCL, which is very conservative in its caching approach. As soon as it sees something that is remotely related to uncacheable data or personalized data, it won't cache, which might be a problem for a real-world application. So you'll need to customize the VCL. But before you can do that, you need to understand how the built-in VCL works. And for that, we advise you to go to our developer portal. It's available on www.varnish-software.com/developers, and it has a tutorial section. And in this tutorial section, you'll find an article, a tutorial about the built-in VCL. It explains in detail how Varnish approaches the various states in the finite state machine and how they're represented code-wise through the various subroutines. Each subroutine is a piece of the puzzle, and this tutorial explains how it is responsible for deciding on when caching takes place and when it doesn't. But you can also use the Varnish developer portal to be inspired and to find other tutorials that might solve individual issues that go beyond the built-in VCL. We would also advise you to go to the Varnish Enterprise documentation, which is available at docs.varnish-software.com. For every component under the Varnish Enterprise umbrella, there is a separate documentation section. And if you go to the Varnish Cache Plus one, you can see all the Varnish Enterprise features, as well as an overview of all the Varnish Enterprise modules that are available. This concludes the basic onboarding video. You've now successfully set up and configured Varnish Enterprise on the AWS cloud. You know how to access it via SSH, you know where the VCL file is located, you know how to manipulate the runtime parameters, you've set up TLS, the storage is in order. The only thing you need to do is now customize your VCL. Good luck with your setup, and thank you for watching.